Commercial drones have outgrown their early days of basic aerial photography. Today, they are heavy-duty, critical infrastructure tools. If you're used to standard prosumer operations, flying manually and swapping out SD cards at the end of the day, you'll quickly find that those habits break under the weight of enterprise demands. The financial stakes are high. Upgrading to enterprise-grade hardware often requires a capital expenditure of tens of thousands of dollars before a single propeller spins. Operational maturity, rather than raw hardware capability, determines whether an enterprise rollout succeeds or stalls. To understand your options, look at the DJI Enterprise ecosystem as a tightly integrated walled garden. It's a closed loop of specific airframes, specialized payloads, and proprietary software designed to work exclusively with one another. You have a wide array of airframes to choose from, ranging from the heavy-lift Matrice 400 and M350 RTK down to the more compact M30 and Mavic 3 Enterprise series. Warning tone: if you pair the wrong ZenMuse payload or software package with your chosen airframe, your budget is effectively wasted on tools you can't deploy. This diagram is the Enterprise Deployment Matrix. We use this to map exact hardware combinations to specific industry constraints. It splits into three paths: time and speed, accuracy and data, and scale and automation. Before you ever look at a spec sheet, you must rigorously identify the single biggest friction point in your daily operations. Let's follow this first path for public safety. Here, the absolute primary constraint is extreme time sensitivity and the need for immediate situational awareness. For these missions, agility dictates the hardware. The Matrice 30 series, or the Mavic 3 Enterprise Thermal, are ideal because they can be deployed from a trunk to the sky in under 2 minutes. When ground teams are navigating active, hazardous environments filled with smoke or debris, seconds count. Having immediate thermal and high zoom capabilities dictates exactly where crews are sent. The next step up is the Dock as a first responder model. Using the DJI Dock 2 or Dock 3, departments can completely automate remote launches the second an alert comes in. However, there is a hidden operational friction point. Deploying drones from a remote dock legally requires obtaining Beyond Visual Line of Sight, or BVLOS, regulatory waivers. While agile hardware provides immediate tactical advantages on the ground, a fully automated dock deployment is useless without prior clearance from aviation authorities. Shifting to our second industry path, the Matrix focuses on surveying and AEC professionals. Their primary constraint is securing sub-centimeter topographical accuracy. To achieve that precision, you need a heavy-lift airframe like the Matrice 350 or 400. They are built specifically to carry advanced, high-weight surveying payloads. This is where tools like the ZenMuse L3 LiDAR system come in. They map highly complex topographies or penetrate dense forestry in a single continuous flight. The massive scale of these surveying environments, like this multi-tiered open-pit mine, justifies the high cost of collecting such dense spatial data. The primary friction point for surveyors isn't the flight itself, it's the resulting data avalanche generated by gigabytes of laser returns and high-resolution images. To process all that ZenMuse data into actionable 3D models and point clouds, you have to use DJI Terra software. The hidden cost of DJI Terra is the hardware you keep on the ground. It demands significant on-premise computing power to process massive file sizes natively. Investing heavily in high-end aerial LiDAR hardware yields a negative ROI if your IT department lacks the physical infrastructure to process the data. Our final path targets enterprise fleet managers, where the primary constraints are large-scale operations and remote automation. For this workflow, DJI Flight Hub 2 is the essential cloud-based software. It allows managers to coordinate multiple drones and stream live feeds directly to command centers. Flight Hub 2 enables perfectly repeatable, autonomous flight paths, completely automating your routine vertical scans and complex structural inspections. Remote large-scale infrastructure like wind farms span vast distances, making them ideal candidates for this kind of persistent, automated monitoring. To achieve true remote automation, you must overcome steep enterprise data security concerns and ensure flawless cellular network reliability across your entire deployment site. The Enterprise Readiness Scorecard measures prerequisites across all three profiles. For hardware, geospatial requires heavy capex, while public safety has a low entry point. For IT, surveyors need on-premise computing, contrasting fleet managers' cloud security. Finally, automated docks face the highest legal hurdles. Failing to check the IT and regulatory boxes makes your top-row hardware investment essentially useless. The drone itself is just the starting point. The real investment is in software, IT data infrastructure, and legal groundwork. Here are your final rules of engagement. For public safety, prioritize agility above all else. Avoid heavy, complex payloads that slow down launch times. In volatile, unpredictable environments, getting eyes in the sky immediately is always more valuable than capturing perfect data resolution. For geospatial, if your deliverable is a digital twin, you must purchase heavy-lift airframes like the Matrice 350. But do not buy the drone until your Terra processing pipeline is built and tested. For industrial inspection, automated dock networks are highly effective, but only if your legal team has already secured your BVLOS waivers. Avoid the temptation to buy the most expensive, feature-rich drone simply because your budget allows for it. Investing in DJI Enterprise is a commitment to a full, continuous data pipeline. True success requires building an organization fully capable of handling that data, alongside training the pilots who capture it.